Hello everybody, my name is Krishna.Kishore and welcome back to my channel. Hope you are learning something on each and every day to keep up yourself in the market as the learning must go on. So far we have went through about the various topics under the Docker, like introduction about the Docker, importance of Docker, drawbacks of virtualization, architecture, the basic and the advanced commands of Docker which we use on the daily basis, how to manage the data with Docker through volume and bind mount, what is the importance of networking in Docker, how does it help in optimizing the Docker while working with various containers or the microservices of a given application, how to understand the existing or write the new Docker files from simple, medium to complex level, and how to write the Docker Compose files when we are dealing with the multi-level or when we are dealing with the several services or the microservices of a given application. Let's say if we are setting up an application which consists of front end, back end and the database, so it's always wise to go with the Docker Compose. So we have covered all these topics, and if you haven't went through these sessions, I'll share the link in the description. Please go through, and we have the real-time practical examples of each and every session. So practice, clone the repo in your local machine and practice it. If you have any question, do please comment in the section. I'll get back to you. We are exploring about security of Docker with the Trivy tool, and I think you will find it really insightful, so stick around till the end of the video. The problem statement over here is that when we are working with Docker, the security is at top priority. In the sense, when we are working with Docker, there are high chances of having the vulnerabilities in Docker image, operating system, packages and libraries, file system, etc. What is vulnerability? It's a flaw or a gap in the system which would ease the attackers to exploit the secrets or confidential data. So our Docker image or the operating system may have the secret or the confidential data, and if the image, operating system or the file system have any flaw or the gap as a vulnerability, the attacker can easily exploit it. And it usually happens when we work with the open source softwares like PostgreSQL, Spring Boot, etc. Because we never know who and when have injected the vulnerabilities, and by using these softwares, if we are building our application and that application may have the secret or the confidential data which would ease the attacker to exploit them. And this is where the Trivy comes into the picture. So what is a Trivy? It is an open source vulnerability scanner tool to identify and scan images, operating system packages or libraries and the file system of the container and help in fixing them. I'll repeat it for you. Trivy is an open source vulnerability scanner tool which helps in identifying and fixing the Docker image, operating system package and the libraries and the container file system, etc. How it helps to fix them out is when we run the Trivy against these artifacts, it creates an output file showing the details of the vulnerabilities and also advising or suggesting us to fix them. We'll see in a while how that really happens in an example. So why Trivy is so popular is the question what arises is that is Trivy only the tool available across the market to do such activity, and why Trivy is so popular. The reason being is that Trivy being the open source, as we just said, it is very easy and faster to implement. And along with that, it is very easy to integrate with the CI/CD pipeline. Why? Because as we are building up the applications, so we write the CI/CD pipeline to build and deploy the application faster, and as a part of this CI/CD pipeline, we also scan, identify and fix the Docker image, operating system, package on the libraries and the file system. And thus the Trivy being very easy to integrate with the CI/CD pipeline, it has become so popular in the market. So now you may ask me a question that, Kishore, is Trivy only tool available in the market to do such activities? No, there are other tools as well, like Docker's itself, Docker Scout tool, one another one is Sync and Anchor. But all of which the Trivy is so popular in the market. So for each topic so far which we discussed, either it can be the Docker volume, Docker network, Docker file and the Docker compose, we illustrated with an real-time example, and over here as well we're gonna try and understand how Trivy helps us in doing this task. So the example over here is that we have I have taken over the example of the previous session, which is the Docker compose, the three-tier architecture compose, and I've made the slide changes by adding up the Trivy as a service. So what we have over here is that we have the front-end application, we have back-end application and the database. These three services were already there. So along with that, I have added Trivy backend as a service and Trivy frontend as a service. So this Trivy backend will scan the backend image, operating system package and the libraries and the file system. Similarly, the Trivy frontend will scan the frontend image, operating systems file system, operating systems package and the libraries and the file system, and it will produce a output file for us. So we'll see how that output file looks like, what are all the details in it, how it suggests and advises in fixing out the issues, not only to just show the vulnerabilities. So let's switch to the terminal and do the practical thingy. Okay, so I have documented and pushed the relevant files and the folders over here under the security with Trivy, wherein we have front-end, back-end and the Docker compose file. So alright, so what we have over here is that we have front-end and the back-end application and Docker compose file. What are we interested over here is the Docker compose file. So this is the same example what we discussed in our previous session in the Docker compose example, wherein we had the DB service, the backend and the front end. What I have added in that example is the Trivy backend as a service, Trivy frontend as a service. So this Trivy backend as a service would scan, identify, and it will produce the Trivy output file for us, suggesting to fix the vulnerabilities. So the command over here is that it is going to take the Trivy as a image. The command is this one, image, producing the output in the table format, and this is a part of the file in the container, and this is the image. If you see this is the directory name hyphen the image name. So the image name is backend over here. Okay, I'll repeat it for you. This is the directory name hyphen image name. Similarly, and it's gonna create the volume over here. Similarly the front end. Okay, so it will, so the Trivy gonna produce the report in this path of the local machine. Okay, so now let's build the application and see how the Trivy gonna produce the output file for us. Docker compose up build. Alright, so now we see the Trivy backend service execution is done successfully, exited with code 0. Similarly, the front end is done, exited with code 0. So we'll just come out of this and we'll see what is there, what was there in our Docker compose file is that it's gonna create the report at this path of the local machine, at this path. All right, so which is the current path, right? So we see the directory report has been created over here, right, over here. So we have these two reports being created. So let's the front end one, right? So we have 26 vulnerabilities over here, right, and it has some explanation as well. Let's switch to the backend. Okay, let's focus only on the backend and see what are all the vulnerabilities and how we can fix them in the real time. So these are, so we have two types of targets over here. One is the operating system one, yeah, and another one is the application, which is the jar file. So in the operating system we have 287 vulnerabilities and 40 vulnerabilities in the application. So there are low 162, medium, high, critical. Let me emphasize this. Okay, we always try to focus on resolving the critical and high vulnerabilities first. At most of the times we may ignore the medium one, but it is wise if we can fix them as well. All right, so what shall we do is that we'll first focus on resolving this high 7 vulnerabilities of backend. And how many are there in, okay, so we have, let me note down this. So this is one thing. Okay, so we have, right, so we have 7, so we have these many total vulnerabilities. Let me copy this way. Okay, and how many are there for jar? Right, so the application, the jar file have these many medium, high and the critical vulnerabilities. So I've just taken them as a backup. Okay, so for now, so far what we have done is that we have scanned, identified the vulnerabilities of the backend and the front end application. All right, so the next motto of the Trivy is to suggest and advise in fixing them, right? So as a DevOps engineer or the developer, we always tend to fix the high and the critical severity, as I just said. Okay, we'll try and focus and resolve the high vulnerabilities of the operating system. Okay, so we'll first see what are the high vulnerabilities and what Trivy has advised us in fixing them, and we'll try to fix and see whether that resolves all the high vulnerabilities for us. Okay, so we'll first grep or search with high for this operating system. All right, so this says that the arbitrary object file permission, so it is basically asking us to upgrade the version of our base image, the base image. All right, we'll see that. What is the next high vulnerability? All right, even this says the same. Okay, the binary utils arbitrary xform. So let's try to upgrade the version of over here as well. Even this says the same. And Kerberos. All right, fine. Okay, all right. Okay, so regarding the operating system high vulnerabilities, will try to upgrade the version of the base Docker image version from the current version to the latest. And then coming to the jar, so we have 15 high and 2 critical vulnerabilities. So we'll first see what are the high vulnerabilities. Okay, so these are the high vulnerability. So what it says is that it is asking us to upgrade the version of Tomcat embed core from this version, from 10.1.20 to either of this version. Okay, we'll do that, and eventually we'll have this dependency mentioned in the backend POM file. We'll see that in a file. What is the next high vulnerability? Is PostgreSQL. Even the PostgreSQL version is asking us to upgrade from 42.6.2 to 42.7.11. All right, we'll do that as well in the POM. And same for the Spring Core, from current version to 6 to 11. Fine, we'll do that. And this one as well, the same Spring framework. Fine. Okay, now we'll see the critical vulnerabilities what we have. Okay, so this is one of the critical vulnerability, the same one what we just talked about. We got to upgrade the version of Tomcat embed core from 10.1.20 to either of this version. We'll do that. Okay, so this way the Trivy output advises us to upgrade the version of the deprecated packages. Therefore, we'll try to upgrade these things and we'll rebuild and see, and we'll try to resolve all the vulnerabilities. Perfect. So what we'll do, firstly, we'll do the operating system 1. Okay, we'll go to the backend Docker file. We'll list the backend Docker file. All right. Okay, so these are the base Docker image which we got to upgrade to the latest version from Maven 3.xxs to latest, and similarly over here as well. Perfect. Okay, this is all about the base operating system or the Docker image fix. Now we got to fix about the application source code or the jar file, and we had them in the POM XML. So one of the change what it advised to do is the Spring Boot version. Okay, Spring Boot Maven version, the Spring Boot plugin. Okay, Maven plugin. All right. Okay, from 3.2.52 it advised us to 3.3.11. Perfect. And we got to upgrade. We have one other place as well, what I remember. Okay, over here as well, from 3.2.5 to 3.3.11. Perfect. The second change was the PostgreSQL. Let's grab with the PostgreSQL. Okay, so this is the PostgreSQL, and we got to update the or pin the version. So let's remove the runtime and instead pin with the specific version. So the version it advised is 42.7.11. Okay, 42.7.11. And one another change was the Tomcat one, the last change, Tomcat. Okay, we don't have the Tomcat dependency over here. So what we'll do is that we try to add that here. Okay, so this is the Tomcat dependency what we got to add, and one another is the Spring Core as well. Okay, we did not we don't have the Spring Core dependency already in the POM file, so we got to explicitly add it. Okay, so we'll add these two versions. Okay, these two package versions in the POM file. All right, let's add them over here. All right. Okay, let's save this. So we have made all the advised changes by Trivy, and now we'll build the application. We'll rebuild the application and see. Docker compose up build. So we see the execution is done. The Trivy backend service successfully completed, exited with code 0. Similarly, the Trivy front end completed, exited with the code 0. All right. So now what we'll do, we'll come out of this execution and we'll see the report now. Okay, we have the report over here. Let's list the backend report as we are focusing on the backend for now. All right, fantastic. Because earlier, let's copy this. So this is the current status of vulnerabilities of our Docker image operating system. Let's copy this and let's paste under this. This is after one, and let's also get the application source code or the jar file current vulnerability. So this is the current status. So what we have, okay, so earlier we had 7 high and 0 critical, and after the Docker image updating the Docker file base image to latest, it has fixed all the high vulnerabilities. And then regarding the application source code, we had 15 high and 2 critical. So after making few changes advised by the Trivy, we have resolved all the high and the critical vulnerabilities as well. So this way the Trivy advises us to fix the vulnerabilities as well, despite of just scanning and identifying the vulnerabilities. It is so beautiful to see, and protecting our application before deploying them onto the production, and protecting the application from the attackers to exploit the secret and the confidential data. Okay, so one more thing which I would like to tell you guys is that it's not only we can run the Trivy as a part of Docker Compose file, we can run them as a separate command as well. Let's say if you wanted to scan, identify and fix the vulnerabilities only for the backend application, let's say, so the command can be Trivy image, your backend image name and the tag. Similarly for the file system, and it will also provide you the output in the table format and in a specified file as well, right? So this way, instead of only mentioning the Trivy in the Docker Compose, we can run as a separate commands as well. But it is not recommended, it is not recommended to run Trivy in Docker file. The reason being is that one of the reasons to run the Trivy is to identify the vulnerabilities in the Docker image. We are creating the Docker image from the Docker file. So when you mention the Trivy in the Docker file, we won't have the Docker image yet created. So it is not advised to run the Trivy or mention the Trivy in the Docker file, but we can mention in the Docker Compose, or we can run the Trivy as a separate command as well. So this is the way how we scan, identify and fix the vulnerabilities of Docker image, the operating system package and the library, and the file system of the container. If you find this video useful, please consider sharing this video across. I will come up with another topic. Until then, cheers, bye bye.